Hello everyone, welcome back to this online class. My name is Francis Okech and my YouTube channel is Professor Francis Okech. Today we are going to look at Calculus 1 and our main topic is on differentiation by first principle. Another name is differentiation by the definition of derivatives, or you can also call it differentiation of the first kind. Now there's this term that we are using, differentiation. What does it mean? We need to understand what we mean by differentiation first before we look at what we are calling the first principle. So take note that if y is a function of x, then what we call differentiation is the process. It is the process of finding the rate of change of y with, that should be with, rate of change of y with respect to x, or simply rate of change of the function. The function can be any function, doesn't have to be a function y, it can be any other function. As long as you are finding the rate of change of that function with respect to the independent variable, then that process is what we are calling differentiation. So for the case where y is a function of x, it means we are going to be finding dy over dx, that is the rate of change of y with respect to x, or f prime of x, still the rate of change of that function. So this process of finding dy over dx or f prime of x, that is what we are calling differentiation. Now the first principle is simply a formula that will give you that derivative. So before I define the first principle, I want us to take note of this. Let's consider this diagram, or consider the graph of y is equals to f of x. It is shown below. I'm going to draw the y-axis vertical line, just a sketch, the x-axis horizontal line. So this is x-axis and this is y-axis. Then let's say our graph is something like this, something like that. Let me draw a better one. Should be just a curve like this. That is y is equals to f of x. Y is equals to f of x. I will need 2 points on this curve. The first point is here, and the coordinate here, let's call this point point A. Coordinate here, let it be x, and on the y-axis, let that coordinate be f of x. I also need another point. Let us call it point B. Call it point B. I'll write it B capital. And the coordinate on the x-axis, let it be x plus the change in x. And the corresponding coordinate on the y-axis, let it be f of x plus change in x. Now this distance, the distance from here to here, forgot this 90, this is change in x from here up to here. That is what I'm calling the change in x. And this other corresponding distance, the vertical distance from here up to here, that will be change in y. So if I join the 2 points A and B with a line, I'll have this kind of a straight line joining the points A and B, and this line is called a secant line. Now, let us talk of another point on the curve. Let's call it point C. Point C on that curve. From this curve, we can get the gradient of the secant line. Can get the slope of secant line AB is simply equal to change in y over change in x. And that, what is the change in y? It is f of x plus delta x minus f of x. And our change in x will be x plus delta x, then minus x. When you simplify, you are going to get f of x plus delta x minus f of x, everything over delta x. And if we let the change in x to be equal to a constant h, then it means therefore the slope here will be equal to f of x plus h minus f of x and everything over h. Now, I want another line that will touch our curve at point C. Or instead of having to draw that line, this is what you are going to do. You take note that if h approaches 0, what you are calling h tends to 0, that's how it's written mathematically. If the change in x approaches 0, then it means that our line, then the secant line will be tangent to the curve at A. And how do you get the gradient of a curve at a point at A whose slope is what you are calling dy dx or f prime of x. Therefore, those two slopes are equal, so we can say that therefore f prime of x or dy dx is equals to, we talk of the limit as h approaches 0 of f of x plus h minus f of x and everything divided by h. So this f prime of x is the same as the limit as h approaches 0 of the other, the slope of the secant line. Look at what we have found here. In fact, I'll bracket this. Very important. What we have found here is called, this is called the first principle of differentiation. This is the first principle of differentiation. Another name is derivatives of the first kind, or differentiation by the definition. But usually we are going to call it first principle. So at some time we may be writing dy over dx or f prime of x. Those are the same thing. You could write dy over dx is equals to limit as h approaches 0 of f of x plus h minus f of x, everything divided by h. So dy over dx is the same as f prime of x. So we can take note that dy over dx is simply the same as f prime of x. They're the same thing. And they mean the rate of change of that function with respect to the independent variable x. So that process of finding that rate of change is what we are calling differentiation. And this formula for f prime of x is called the first principle of differentiation. So let's see how to use this formula to be able to differentiate some functions. We're going to look at 4 examples where we have different functions and we need to apply that formula of first principle to be able to find f prime of x. So we can have examples. Right here, examples. Find f prime of x given the following functions. You're asked to use the first principle. Use the first principle of differentiation. And in part A, the question is f of x is equals to x squared. How do we find f prime of x? Solution. Look at our formula. We need to know what is f of x plus h, and then we subtract f of x from it. So given f of x is x squared, this implies that f of x plus h will be equal to, where there is x in f of x, we are now going to replace it by x plus h. So instead of x, we are going to write x plus h. And remember, this is squared. If I expand it, that will give us x squared plus 2xh plus h squared. Remember, a plus b squared, binomial expansion, you get that. Then, now we need f of x plus h minus f of x. We subtract the 2. What are we going to get? That will give us x squared plus 2xh plus h squared, subtract x squared. And so this is now equal to, because the x squared will cancel, this will cancel with this other one. So that will give us 2xh plus h squared. which you can write as h outside into 2x plus h. That is the numerator. Denominator, we have h. So therefore, by the first principle, so you can just say hence f prime of x is equals to the limit as h approaches 0 of f of x plus h, which is h into 2x plus h. That is the numerator. Denominator, it should be h. Look at the formula, f prime of x. Limit as h approaches 0 of f of x plus h minus f of x, which we have found to be this one, h into 2x plus h, then over h. So that is by the first principle. And you see, in this formula, in this expression, h will cancel with the other h. So this is what we have. Limit as h approaches 0 of 2x plus h. Now, remember the techniques of evaluating limits. It is easier here if we try direct substitution. D dot S means direct substitution. Where there is h, I'm going to put 0. So it is 2x plus h, which is 0. And so the result there is 2x. So that means derivative of x squared should give you 2x. That is from the first principle. Another function is f of x is equals to the square root of x. So we talk of part B, f of x is equals to the square root of x. Again, we need to use first principle to find the derivative of that function. So here, let us find f of x plus h. Let me take this up. We need to find f of x plus h. So we write this implies that f of x plus h is the same as the square root of x plus h. So we now need to subtract the two, f of x plus h minus f of x. So you can say therefore f of x plus h minus f of x, that is the same as, let me use another color, the square root of x plus h minus the square root of x. So now let's go back to our first principle. So we can now say that hence now our f prime of x, when we use the formula first principle, that will give us the limit as h approaches 0 of our numerator will be the square root of x plus h minus the square root of x, and denominator we have h. That is when you use the first principle. So that's limit as h approaches 0. How do we evaluate this limit? You see, as long as the function that you are evaluating its limit involves surds, then use the technique that is called rationalization, because we need to rationalize this function, get rid of the surd from the numerator. Direct substitution will give you 0 over 0, which is not possible. 0 over 0 is not a number, so direct substitution fails in this case, and so that's why we are using rationalization technique of evaluating limit. So this can now be written as limit as h approaches 0 of now. Remember rationalization, you have to multiply the surd by its conjugate. So it is the square root of x plus h minus root x. This one is over h. So we are multiplying numerator by root x plus h plus root x. That's the conjugate of that surd. Do the same in the denominator, root x plus h plus root x. You see what you have done? What you have done in the numerator, you must also do it in the denominator. So this is now equal to, let me open the bracket in the numerator. You see, numerator is the difference of two squares. You take note that a minus b times a plus b should give us a squared minus b squared. So this is a, and this other one is b. Again, this is a, this other one is b. So that it is a minus b times a plus b. So we are going to square a, that is x plus h, and then also square b, you get x. So this will now be the limit as h approaches 0 of a squared is x plus h minus b squared, which is x, over denominator is h into the square root of x plus h plus another root x. That's what we have. And we can be able to simplify this. You see, the x will cancel with this other x, so that this will now give us limit as h approaches 0. Now in the numerator we remain with h. In the denominator we still have h times the square root of x plus h, then plus root x. So that's what we have again. Are we able to simplify this further? Yes, because this and this will cancel. So having simplified that, what do we remain with? So let me write it here. That will now give us the limit as h approaches 0 of 1 over the square root of x plus h plus another root x. So we have simplified that, and now let's see. Once you simplify, you try another direct substitution. Another direct substitution, what will it give us? Where there is h, we are going to substitute 0, so that this will give us 1 over the square root of x plus 0 plus another square root of x. We are only replacing h, remember? It is only h that is approaching 0, so we substitute the value of h, not x. Don't confuse the two. So this is the same as writing 1 over 2 root x, 2 times root x. And so that is our derivative of that function. F of x is root x. So f prime of x is 1 over 2 root x. Another example, I'll write part C. Part C is this function. You are given that f of x is equals to 3x divided by, that is 3x divided by 1 minus 5x. We need to find f prime of x. So again, as usual, let's get f of x plus h. F of x plus h. It means where there is x, you are going to put x plus h. So this will give us 3 times x plus h divided by, sorry, let me write that. So this is divided by 1 minus 5 into x plus h. I can open the bracket in the numerator. You see this is the same as 3x plus 3h over denominator will have 1 minus 5x minus 5h. That's what we have. Now we need to subtract f of x from f of x plus h. So you can say that therefore f of x plus h minus f of x. What will that give us? It will give us 3x plus 3h divided by 1 minus 5x minus 5h. And then this you're subtracting 3x divided by 1 minus 5x. It is better to simplify this. Let us combine those two fractions into one. So I'll have to find the LCM. Our LCM here is 1 minus 5x minus 5h times 1 minus 5x. So that in the numerator we are going to get this 3x plus 3h times 1 minus 5x, then subtract 3x times 1 minus 5x minus 5h. So I can now simplify the numerator. Let me simplify that. Open the bracket in the numerator. So that will be equal to, let me multiply the whole of this by 1. The whole of that by 1 will give us 3x plus 3h. Now, the whole of this again by negative 5x. So that will give us negative 15x squared minus 15xh. That's what you get. Then again, open this other bracket here. That will give us negative 3x plus 15x squared plus 15xh. That is the numerator. And in the denominator, this is what we'll have. 1 minus 5x minus 5h. Then times, you don't need to open the bracket in the denominator, just numerator only, times 1 minus 5x. Take note, just open the bracket in the numerator, not denominator. So let's simplify the numerator. I can see 3x will cancel with this other negative 3x. What else can cancel? Negative 15x squared will cancel with this. And even negative 15xh will cancel with this. So what we remain with in the numerator is just 3h divided by 1 minus 5x minus 5h, then times 1 minus 5x. That's what we remain with after having simplified that function. So now we need to find f prime of x using first principle. So you can just say here, hence Hence, our f prime of x is now the limit as h approaches 0 of the numerator is this f of x plus h minus f of x. We found 3h over 1 minus 5x minus 5h times 1 minus 5x. That's the numerator. So the whole of this, in fact, I can put it in bracket to show that this is numerator. We are dividing this by denominator, which is h. Very important. So let me put these brackets. So you see, this thing can also be written as limit as h approaches 0 of 3h divided by h times 1 minus 5x minus 5h times another 1 minus 5x. That's what we have. And this is in bracket. So you see now the h will cancel with this h. So that what you remain with is now this one. Let me write it here. We now remain with the limit as h approaches 0 of 3 in the numerator. Our denominator is 1 minus 5x minus 5h times 1 minus 5x. So that's what we have. This is in bracket. So having simplified that one, let us now try direct substitution. So when we use direct substitution, where there is h, you are going to substitute 0. What are we going to get? It will now give us 3 in the numerator over 1 minus 5x minus 0. Remember, h is 0, so 5 times 0 is 0. Then another 1 minus 5x. A point to take note of is that we are replacing h but not x. And so this will give you 3 over 1 minus 5x is a negative, and this is supposed to be squared. So when you differentiate the given function, which is 3x over 1 minus 5x, you're supposed to get what you have found. That is 3 over 1 minus 5x squared. That is from the first principle of differentiation. Another example is now when we have a trigonometric function. Let me write it as part D. For example, number 4. So in that case, I'm going to write it. In example number 4, this is the function, part D. We are told that f of x is equals to cosine of x. You're asked to find f prime of x using the first principle of derivatives or differentiation. So from here, when you're given f of x to be cosine of x, we can be able to find f of x plus h. Where there is x, you put x plus h, so that is cosine of x plus h. I want us to recall the identity, what we call the addition formula for cosine, cos A plus B. recall, take note that when we talk of cosine of A plus B, this should be equal to cosine of A times cosine of B minus sine of A times sine of B. This is the addition formula for cosine. So in this case, our A is X and our B is H. So let us expand this. This will now give us cosine of X, cosine of H, minus sine of X, sine of H. So now I want to subtract. You can now say therefore f of X plus H minus f of X. What should it give us? That should give us cosine of X, cosine of H. Remember, this is cosine of H. Don't confuse it with the hyperbolic cosine. Again, here, don't confuse with the hyperbolic sine. Very important. So I'll use bracket there. Then minus sine of X times sine of H. This should be in bracket, so that we don't confuse that with the hyperbolic sine of H. Now, this is the first bracket for f of X plus H. Then we are subtracting f of X, which was cosine of X. So when you subtract, look at cosine of X is common. I'll factor out cosine of X, cos X common. Inside we have cos H, this should be in bracket, minus 1. Then minus sine X times sine H, sine H, that one. So now, how do we now find f prime of X using the formula? You can now write hence f prime of X will be equal to numerator is the whole of this. So we are going to write, of course, it is limit. It is limit as H approaches 0 of our numerator. Let me use another color. Cos X times, can use this kind of bracket. This is cos H minus 1 minus sine X times sine H. That's our numerator. Our denominator is H. So how do we evaluate this limit? This limit can be subdivided into two parts. We can write this as the limit as H approaches 0 of cosine of X times cosine of H minus 1 over H. That's the first part. Then we have minus the limit as H approaches 0 of sine X times sine H divided by H. And you see, when we talk of limit, anything that does not depend on H, you can factor that out. So those, the functions of X, we can factor them out, so that this you can write as cosine of X outside then times limit as h approaches 0 of cosine of h minus 1 over h. Then here we again factor out sine x. Inside we have limit as h approaches 0 of sine h, that is sine h, everything over h. So we have these ones. Now, I want us to take note. We are going to write a note here that this limit, you see the limit of cos h minus 1 over h, this limit is always equals to 0. And the limit of sine h over h as h approaches 0 is always equals to 1. So that what we have here is that f prime of x is now cosine of x times 0 minus sine of x times 1. So that what you are going to get finally is negative sine of x. So that tells you that when you differentiate cos x, you need to get negative sine x. We have used the first principle of differentiation. So thank you all for watching this video. Before I conclude, let me give you some 3 functions to try at your own time so that you ensure that you master this concept of first principle. So you can write exercise, use first principle to find f prime of x. Given in part A, let me use another color. In part A, you are told that f of x is equals to, let me give you this one. It is the square root of 6x plus 2 minus 5. The minus 5 is outside the square root. In part B, you are told that f of x is equals to 1 over the square root of x plus 2. And in part C, you are told f of x is equals to sine of 2x. Sine of 2x. So try these ones at your own time. When we meet next time, we look at other problems in differentiation or other techniques of differentiation. Please subscribe to my YouTube channel, that is Professor Francis Okech. When you go to the YouTube search, type Francis Okech or Prof. Francis Okech and you'll find me right there. Also, don't forget to comment, like, and also share this video. Let's meet next time. Bye-bye.